So this is the group work for college algebra. It goes along with section 5.5, the front side, where we combine like terms and we look at when we're adding polynomials, subtracting polynomials, and a little bit at the end doing the distributive property with polynomials. So basically, in these situations, we want to make sure that we're lining up things that have the same exponent on the same variable. Those are the things that are like terms that we can combine. In problem 1, since there's a positive outside here, nothing outside here, we really can just drop these parentheses without worrying about changing anything that's inside. As we do that, I'm going to write next to each other things that have the same variable to the same power. So when I bring down this 3x squared from the first parentheses, I'm going to look for something that's an x squared term in the second parentheses. I see this negative 4x squared. As I bring down this positive 6x in the first parentheses, I'm also going to bring down this positive 8x from the second parentheses. Finally, I have minus 1 that has no power of x in the first one, and I have plus 5 that has no power of x in the second one. Now that I have things next to each other that are like terms, I can combine them. A positive 3 minus 4 gives me negative 1x squared. A positive 6 plus a positive 8 gives me positive 14x. And finally, a negative 1 and a positive 5 combine to give me positive 4. So my final answer is negative x squared plus 14x plus 4. For the second problem, I can do the same general thing. I just have 3 parentheses to worry about. So my goal in each parentheses is to pick out things that first have the highest power of x I see, and then each power of x on down. So the highest power of x I see across everything is 5x squared and 8x squared. I'm going to put those terms at the start. 5x squared plus 8x squared. Next thing I see is just x. So here I have a positive 4x. Here I have a positive 3x. And here I just have a positive x. Finally, the things with no power of x, I have a negative 2 here, a positive 9 here, and a positive 8 here. When I look at the x squared terms, I'm adding 5 here to 8 here to get a total of 13x squared. When I look at the x terms, I'm adding 4 here to 3 here to get 7, and then 1 more gives me a total of 8x. When I'm looking at the numbers that don't have x's with them, negative 2 and positive 9 combines to give me positive 7. When I add 8 to that, I get a total of 15. So my final answer is 13x squared plus 8x plus 15. Number 3 is the first time where I can't just drop parentheses. This time that negative sign is very important. It not only means that I change this first negative 3x squared to a positive 3x squared, but I'm also going to change the sign on positive 2x. I'm also going to change the sign on negative 1. So what I'm really doing is multiplying through this negative to each part of the problem. When I do that, it's really going to become plus a positive 3x squared minus 2x plus 1. So what I really did to distribute that negative sign is take what was negative, positive, negative, and changed all 3 signs. It became positive, negative, positive. If I now drop parentheses and write things next to each other that belong together, this 6x squared and this 3x squared go together. 6x squared plus 3x squared. This positive 4x and this negative 2x go together. Finally, this negative 6 and this positive 1 go together. When I now combine like terms, 6 plus 3 gives me a total of 9x squared. Positive 4 minus 2 gives me a total of 2x. And negative 6 plus 1 gives me a total of negative 5. So my final answer is 9x squared plus 2x minus 5. Again, I'm going to begin problem 4 by distributing that negative. The negative sign outside the second parentheses goes to each thing inside the parentheses. What used to be an 8x squared now becomes a negative 8x squared. What used to be a negative 9x becomes positive 9x. And what used to be a positive 6 becomes negative 6. Once each of the signs are changed, I'm just dropping the parentheses. This positive 2x squared gets combined with this negative 8x squared. This positive 1x gets combined with this positive 9x. This negative 5 gets combined with this negative 6. When I add everything together, 2x squared minus 8x squared gives me negative 6x squared. Positive 1x plus 9x gives me positive 10x. Negative 5 minus 6 gives me negative 11. So my final answer is negative 6x squared plus 10x minus 11. For problem 5 and 6, I have more than just a negative sign outside parentheses that I got to deal with. I have something that needs to be distributive to each thing on the inside. So my first step is going to be to do this distributive property. After I do the distributive property, I'm going to combine like terms. So the first parentheses, 2 times x, gives me 2x. 2 times 3 gives me 6. 4 times x gives me 4x. 4 times negative 2 gives me negative 8. Now that I've got it distributed out, I'm going to write things next to each other that are like terms and can be combined. Specifically 2x plus 4x and positive 6 minus 8. 2x plus 4x gives me a total of 6x. Positive 6 minus 8 gives me a total of negative 2. So my final answer to this problem is 6x minus 2. When I go to do the distributive property in problem 6, most common things that students forget is either not to multiply each thing on the inside or not to include that negative as part of what's being multiplied through. In each of these cases, it's not only the number outside that's being multiplied through, but also the negative sign that goes with it. So I'm going to take this negative 2 and multiply it by each thing on the inside of this parentheses. Then I'm going to take this negative 3 and multiply it by each thing on the inside of this parentheses. When I do negative 2 times x squared, I get negative 2x squared. Negative 2 times a positive 7x gives me negative 14x. Negative 2 times a negative 1 gives me positive 2. Negative 3 times x squared gives me negative 3x squared. Negative 3 times negative 2x gives me positive 6x. Negative 3 times positive 2 gives me negative 6. If I now write the like terms next to each other, this negative 2x squared is a like term with this negative 3x squared. This negative 14x is a like term with this positive 6x. This positive 2 is a like term with this negative 6. When I combine the like terms, negative 2 minus 3 more gives me a total of negative 5x squared. Negative 14 plus 6 gives me a total of negative 8x. Finally, positive 2 minus 6 gives me a total of negative 4. So my final answer there is negative 5x squared minus 8x minus 4. This is the second half of the group work where we're multiplying and dividing these polynomials. The first two problems asked me to take a monomial, one term on the outside, and multiply it by a polynomial, multiple terms on the inside. So what I'm really doing is taking each of the terms inside and multiplying it by this negative 2x that I see outside. So in the end, there's going to be 1, 2, 3, 4 multiplication steps. I'm going to write them out explicitly over here. So I'm taking negative 2x times 5x to the third. Then I'm taking negative 2x times 3x squared. Then I'm taking negative 2x times 6x. And finally, I'm taking negative 2x times negative 7. When I do negative 2x times 5x to the third, negative 2 times 5 gives me negative 10. X to the first plus x to the third gives me x to the fourth. Negative 2 times positive 3 gives me negative 6. X to the second times x to the first, 1 plus 2, gives me x to the third as the final exponent. Negative 2 times positive 6 gives me negative 12. X to the first times x to the first is 1 plus 1, or x to the second. Finally, negative 2 times negative 7 gives me positive 14. There's no x here, so it's just x to the first power that comes from that. So my final answer is negative 10x to the fourth, negative 6x to the fifth, negative 6x to the third, negative 12x squared, plus 14x. When I go to do problem 2, again, my goal is to take what's outside and multiply it by each thing that I see inside of the parentheses. So it's going to become x to the fifth times x to the sixth, plus x to the fifth times 5x to the third, plus x to the fifth times negative 2. 5 plus 6 gives me a final exponent of x to the 11th. I'm going to add to that 5 plus 3 gives me an exponent of x to the 8th, still being multiplied by this coefficient 5. So 5x to the 8th. Negative 2 times x to the 5th gives me negative 2x to the 5th. So my final answer there is x to the 11th plus 5x to the 8th minus 2x to the 5th. When we get down to problems like 3 and 4 and really 6 and 5, you can definitely do these by the FOIL method if you're good with it and you know how to do the FOIL method. But I always like to see them as double distribution, where I'm basically taking this first term times the whole second parentheses, the second term times the whole second parentheses. So I'm doing it as x times x minus 7 plus 5 times x minus 7. X times x gives me x squared. X times negative 7 gives me negative 7x. 5 times x gives me 5x. 5 times negative 7 gives me negative 35. There's always one pair of like terms, the middle. This negative 7 and this positive 5 combine to give me negative 2x. So my final answer is x squared minus 2x minus 35. When I go to do the same for problem 4, first term 6x times whole second parentheses x minus 1 plus second term 2 times whole second parentheses x minus 1. 6x times x gives me 6x squared. 6x times negative 1 gives me negative 6x. 2 times positive x gives me 2x. 2 times negative 1 gives me negative 2. Combining the like terms in the middle, negative 6 plus 2 gives me negative 4. So my final answer is 6x squared minus 4x minus 2. Number 5 is a little trickier because there's this third thing outside. It's not just me multiplying this times this. I have this extra x out here. I'm going to leave that extra x outside as I do the same math I've done above to this x plus 10 times x plus 8. So there is an x outside of all this, but I'm basically taking first term, x times whole second parentheses, x plus 8. Second term, 10 times whole second parentheses, x plus 8. When I do this, the x is still there to be multiplied through. This x times this x gives me x squared. This x times this 8 gives me 8x. This 10 times this x gives me 10x. And this 10 times this 8 gives me 80. And now I can leave the x outside, combine like terms in the middle. 8x plus 10x is 18. So inside I get x squared plus 18x plus 80. My last step is to basically do what I did above with this single term being multiplied through. And this term multiplying through by an x is basically, since it's x to the first being multiplied by each of these things, just adding 1 to the current exponent. So what used to be x to the second becomes x to the second plus 1, or just x to the third. What used to be 18x to the first becomes x to the first plus 1, or 18x to the second. Finally, when I multiply 80 by x, there's nothing to combine with as far as another exponent on the same base. So I just leave it as coefficient 80 times the x that I did there. So my final answer is x cubed plus 18x squared plus 80x. Basically, the answer that I got from doing double distribution, x squared plus 18x plus 80, with everything raised by 1 power of x. When I get a problem like number 6, I basically want to turn it into one like 3 or 4, by just rewriting what it means for something to be squared. It means for it to be multiplied by itself. So this is really x minus 3 times x minus 3. If I write that as double distribution, it's the first term, x, times the whole second parentheses, x minus 3. The second term, negative 3, times the whole second parentheses, x minus 3. X times x gives me x squared. X times negative 3 gives me negative 3x. Negative 3 times x gives me negative 3x. Negative 3 times negative 3 gives me positive 9. Combining the like terms in the middle, this negative 3 and this negative 3 combine to give me negative 6x. So my final answer is x squared minus 6x plus 9. When I go to do number 7, I really have to do two distinct double distribution problems. I then need to distribute a negative and combine like terms. So this is like putting together 3 problems from what we've done before. It's definitely a lot of work, but let me show you how I would do it. I'd take this x times the whole thing, 4x plus 1. Then I'd take this negative 2 times the whole second parentheses, 4x plus 1. On this side, I'm going to take this negative and leave it outside of everything that's going on here. It might be easier for you to see as this negative changing 2 signs here and then go from there, but I think it's going to be less confusing if I put it outside and just change the 3 signs at the end. So on the inside here, it's this x times this whole second parentheses, 5x minus 1, and then it's this positive 4 times this whole second parentheses, 5x minus 1. X times 4x gives me 4x squared. X times 1 gives me x. Negative 2 times 4x gives me negative 8x. And negative 2 times positive 1 gives me negative 2. Minus what happens in parentheses here is x times 5x is 5x squared. X times negative 1 is negative x. 4 times 5x is plus 20x, and 4 times negative 1 is minus 4. My next step down, I'm just going to rewrite these 4 terms, and I'm going to switch the signs. Or I'm sorry, I'm not going to rewrite these 4 terms. I'm going to combine the middle term as I go. So I'm going to leave it as 4x squared. Positive 1 minus 8 leaves me with minus 7x, and then that minus 2. As I distribute this negative, really I'm combining these 2 middle terms. So I'm using 5x squared plus 19x minus 4. When I change the sign on positive 5x squared, it becomes negative 5x squared. When I change the sign on positive 19x, it becomes negative 19x. And when I change the sign on negative 4, it becomes positive 4. And now I'm going to combine like terms. 4x squared minus 5x squared minus 7x minus 19x minus 2 plus 4. 4x squared minus 5x squared leaves me with negative 1x squared. Negative 7 and negative 19 combine to give me negative 26x. And then negative 2 and positive 4 combine to give me positive 2. So I get negative x squared minus 26x plus 2 after going through all that math. This is a little beyond what I need you to do for the class, but it definitely is good practice having to do out these double distributions. These types of problems definitely come back a lot in future maths. These are a type of thing that you will see more often than some of the other things we cover in class. Problems 8, 9, and 10 come from this division section. Really, 8 and 9 look very similar to problems that we did when we were talking about rules of exponents, and we do it a similar way to when we were doing rules of exponents. Here, I like to say, where is there more, top or bottom, and how many more? In this case, we're talking about the x's. We have x to the 8th on top, x to the 2nd on bottom. There's more on top. How many more? 8 minus 2 is 6 more on top. So the 3 coefficient has been unaffected. The x's went to 8 minus 2, which is 6. So my final answer is 3x to the 6th. For problem 9, it's a little more complicated. I start out by looking at the coefficients, 27 on top, 9 on the bottom. They share a common factor of 9. 9 goes into 27 3 times, 9 goes into 9 once. So basically I'm left with a 3 on top and a 1 that's on bottom that I don't really need to write. I now look at the x's. I say which is larger, a 7 or a 2? 7's larger. How many larger? 5 larger. So there's an x to the 5th that stays on top. In the y direction, I have 3 on top, 6 on bottom. 6 is bigger. How many bigger? Well, 6 minus 3 would leave me with 3. So there's a y to the 3rd on bottom. Z to the 5th on top, z to the 4th on bottom. Which is larger? Z to the 5th is larger. How many larger is it? Well, 5 minus 4 would leave me with 1. So I could write it as z to the 1st, but I'm just going to write it as a z. My final answer is 3x to the 5th z over y to the 3rd. This last type of problem, number 10, I really just include because it is there in your web assigned homework. Basically, the skill here is to say, well, if they're both over this joint denominator of 2, I can split it into 2 separate fractions that I can reduce. The first one is the first term, 14x, divided by the denominator 2. Then I keep whatever sign is between them, and I do the second term, in this case 2, being divided by the denominator 2. I can then look at what these reduce to individually. 14 divided by 2 leaves me with 7x plus 2 divided by 2 is 1. So again, if I've got 2 things being added in the numerator over a single denominator, I can split that numerator to have each part over the denominator and reduce it, where in this case my reduced final form was 7x plus 1.